Let's talk about graphs. I think you may already be familiar with the graph data structure, but it's the reason I wanted to talk about it is because it's a very popular data structure, and it has a lot of applications. There are a lot of problems which can be modeled using graph. For instance, you have this transportation system, the road transportation system. You have these applications like Uber and all, in which you are trying to find the shortest distance between different places. Also, you have these social networking sites like Facebook, Twitter, and all, and they are also somewhere using basic graphs, the basic graph data structure. So in that sense, it's a pretty popular one, and it's not that difficult to understand. If you have the basics in place, then you can try to solve a lot of problems that you encounter using graphs. So in this article, I'll just give you a summary of graphs. You can read my blog on that, the link to which is provided in this video. So let's talk about this simple graph. It's a friendship graph, and as you can see, I have like a small set of six folks who are kind of connected to each other. So if you see here, Ankur is friends with Dikshit and Reena. I've just taken a very simple scenario, not to make things complicated. And if you see, then Dikshit is like friend with Suresh and Mohan. So this is how a basic graph may look like. These are like your nodes or vertices in graph, and these are edges in graph, which is straightforward. Now, so far so good. How are you going to maintain this structure in your system, in your computer? How are you going to program it? So for that, you have a couple of approaches. You have adjacency matrix and adjacency list. Now, matrices are also a good way of storing graphs. So in matrices, you can create a matrix with each of these nodes, as rows and columns, and then if you have an edge between any two nodes, you can highlight that in your matrix. The problem is that matrices take a lot of space, and that's the reason the other popular approach is used, which is adjacency list. So if you see this list here, what we do is we have an array of all the vertices that we saw in our graph. So you have all these names stored in an array, and then each element in the array has a corresponding linked list. So here since Ankur is friends with Dikshit and Reena, so we maintain a list for Ankur here. And similarly, we maintain the list for other edges. Now this is really compact, it's not taking that much space which a matrix is taking. So this is one of the popular ways. If you have a sparse graph, sparse means like uh, you don't have edges between each of the two nodes. I mean, it's not a complete graph. So Dikshit is not connected with everyone here. So why waste space in a matrix, right? So I think you got an idea. Now coming to the program, if you see the program, which is a part of the article, or you can view it on GitHub directly, I'll post a link for that. Then if you see, it's a very basic program in which I've considered this vertex which has a label. Label is basically like 0, 1, 2, 3, 4. Why I have taken the label, this label attribute is because I wanted to store the vertices in the array basically. So that's the reason you see this label. Then you have name corresponds to the name you see in the graph, and next is used because we want to maintain a list against each vertex, right? So the program is pretty straightforward. You may like to go through it, or you may want to try it before you see this graph. Essentially what I am doing is I'm trying to first build the graph that we see here in this format. So it's like I'm adding to the list all the edges that you see. So edges means like this is label 0, this is label 1. So 0, 1 has an edge, 0, 2 has an edge. 1 3 has an edge, 1 4 has an edge. Likewise, I've just constructed basic edges. And prior to that, I've initialized the array. I mean the array that you see here, this has been initialized first using this block of code. Then the edges have been added. So this is essentially like adding what you see here, creating array, building the list, and that's it. So once you are done with that, then you can traverse the graph using this method, and it's a pretty straightforward method in which I'm going through each vertex in the array, and then for each vertex I'm traversing the list that is there, right? So you see a few loops here, right? And there are other methods which are self-explanatory, so I am not going to walk through each of those. You can take a look at this code. If you have questions, you can drop a comment or write to me at the post. So I hope this gives you a basic introduction. In the next one, I'm going to talk about breadth first traversal of graph, which is a very popular approach for traversing graphs, and I hope that helps you. Okay, thanks guys.